So, but here he gave the definition. See. Local maximum and local minimum. Already I explained you what is local maximum, local minimum, but the further definition is there. What is the definition you see? Here H is some small positive quantity. Okay. C is called a point of local maximum. When if there is if there is a positive quantity such that f of c is greater than or equal to f of x for all x in the interval c minus h and c plus h. C, it is neighborhood of C. So this is what is neighborhood of C. Yes or no? This is C and in the neighborhood of C. C minus H only when X belongs to C minus H and C plus H. Okay. Only when X belongs to C minus H and C plus H only. F of C is, that means what? In this interval, okay, in this interval, F of C is maximum. See, F of C is always greater than input F of X. What is X? X is in the neighborhood of C. This is called neighborhood of C. Neighborhood of C. Okay, neighborhood of C. Okay.
Yes, sir.
Yeah, then in the neighborhood of C, if it is always less than, that means what? It is minimum, local minimum. Okay.
Yes, sir.
That is definition, not the. That's only definition. So, but first principle, what is the first principle that we learned now? Is this. First principle is this. Yeah. Here again it is given. Okay. So the next. So here the function is defined on the open interval I. Suppose C is in the interval I. Okay, any point. If f is local if f has a local maximum or has a local minimum at x equal to C, then either f dash of C is 0 or f is not differentiable at C. You understand what does it mean turning point? F dash of C is 0 means what turning?
Yeah.
But here some small difference is there. If you notice, there is a small difference. What is that? So here thing is that if at all at C at x equals C, f has either maxima or local minima, local maxima or local minima, definitely f dash of C is 0 or f is not differentiable. F is not differentiable. That's what it said. So what does it mean? We'll see now. You understand? So now here I'll give you example. I'll give you now here this one curve and this another curve. This is one curve. I'm drawing this one curve. You know this one curve, and and then this is another curve I'm drawing. This is another curve I'm drawing. Okay, and then this is one more curve I'm drawing. And this is what I do. So now this one. So here this I am saying, this I am naming as C. So here f dash of C, that means what here? At C it has maximum. At C it has
Max.
F has maximum. That means what? F dash of C is 0. Yes or no? That's what is.
Yeah.
If it has local maximum or local minimum. Now this also I am naming as C. At C, f dash of C is 0. And it has local minimum. If f has either local maximum or local minimum at C, then f dash of C is 0. But this is not the case for all. Or another point is there. Here also, you know what? This is what 0, and its minimum value is 0. And at 0, okay, this is the x-axis, y-axis I wrote wanted because always f of x is mod x, So it's not differentiable, that's the reason I have taken this function. And here, at x equal to 0, f has minimum, this minimum doesn't mean here f has minimum. We can say here also f has minimum, where minimum at x equal to 0 doesn't mean that f dash of 0 is 0. No. Actually, f dash of 0 doesn't exist, F of AC differentiation doesn't exist for mod x, where at 0. You remember? We discussed this.
When x equals 0.
At 0, yeah. F of x we discussed, right? Minus x if x is less than 0. x if x is greater than 0, 0 if x is 0. And
Yeah.
right hand derivative is -1. Right hand derivative is +1. Where it is.
Yeah.
So therefore it is not differentiable at 0. So what he's saying is if f has either maximum or minimum, then f dash of c is 0 or f is not differentiable. Also the case. Okay.
Mhm.
If
Yeah.
is local maximum or local minimum means what f dash of c is 0 is one possibility. Another possibility is f is not differentiable is another possibility. Here also, here let's say this is c. You know what? F is maximum at x equal to c in this case. See, in this case, f has maximum at x equal to c. But here f dash of c, you can't say f dash of c is equal to, you can't say f dash of c doesn't exist, you should say here in this case. Okay, that's
Yeah.
what you're saying, either 0 or doesn't exist. In this case also, it has maximum. In this case, it has minimum. Let's see, let's say here it's c. It has maximum, but because it is that, you see, it is what? It is a vertex. So f dash of x here also in this case, f dash of x doesn't is not defined here also. F dash of c is not defined because it's also vertex. So vertex will be there. Sometimes vertex will be there. Sometimes ending point here also. Here also ending point. Ending point also tangent you can't draw. That means not differentiable. So there, what the conclusion is that if at all a function has, if at all a function has local maximum or local minimum, then either f dash of c is 0 or f is not differentiable at c.
Okay.
This is a very good example to understand. What is that? Converse also not true is what. So, if at all f dash of c equal to 0, then c need not be point of local maximum or local minimum.
Okay.
Of c equal to 0 doesn't mean that always it's a turning point.
Yeah.
Doesn't mean that always it's a turning point. Sometimes may not be. Yeah.
Mhm.
Now x equal to 0 is there. X equal to 0. Now, what is f dash of x is not 3x square. So if you put 0, f dash of 0 is 0. That means what? At 0 it should turn actually, but here this is not turning point. This is point of inflection.
Okay.
But what is point of inflection? That means what? It doesn't have minimum or maximum. That point of inflection. So therefore, here this is also important. If f dash of c equal to 0, then c need not be point of local maximum or local minimum or turning point. May not be turning point sometimes.
Mhm.
This also, previous one what we discussed, local maxima, c is point of local maxima or local minima, then f dash of c is 0 or another possibility is also. Okay. So now what we are discussing, f dash of c equal to 0 doesn't mean that c is point of local maxima or local minimum. This is also not.
Yeah.
F dash of equal to 0 means c can be point of inflection. Okay. But
Yeah.
local minima we can find out by using second derivatives. But point of inflection, if it is point of inflection, then what we should do, we have to go for first derivatives. Yeah. We are coming to first derivatives. Before that, this note is here. Here, one very important note is there. What is critical point? a point C in the domain of F, at which f dash of C equal to 0 and F is not differentiable, is called critical point of F. Either f dash of C equal to 0 or F is not differentiable is called a critical point. Okay. F dash of C is 0 also no problem, or F is not differentiable also, that's called a critical point. What is the difference between turning point and critical point? Turning point means what? Turning point means this. Critical point means what? This also. Both are called critical point. This also critical point, this also critical point. So that means what? Critical point means either not differentiable or f dash of C equal to 0. F dash of C equal to 0 also okay, or f is not differentiable. In this case, C, f dash of f is not differentiable. In this case, it is differentiable and 0. That point you should note. Is that okay?
Yes, sir.
Understand? F dash of C equal to 0 are not differentiable. F dash of C equal to 0 also okay, not differentiable also okay. F dash of C equal to 0, turning point we call. Not differentiable, what we say the vertex is. Yes, but these two together we can call critical point.
Yeah.
That's what I think.
Yeah.
So, chalo, first derivative test. First derivative test again, remember, what is that? Let f be the function defined on the open interval I and f is continuous at the critical point C in I. Then f dash of x changes. See, that's why f dash of x changes sign positive today. Positive means what? You know, positive means what? Increasing. Yes or no?
Yeah.
Positive f dash of x derivative. F dash of
Yeah.
changes its sign from positive to negative. That positive means increasing. F dash of x positive greater than 0 means increasing. Increasing, then decreasing. That means what? Through C, f dash of x is greater than 0 at every point sufficiently close to and left side of C. Sufficiently close to C and left side of C increasing. Sufficiently right to C and right side of C increasing. Decreasing and increasing means it will have local maxima. Similarly, and it's changing sign from negative to positive. That means dash of x is less than 0 and if dash of x is greater than 0, negative to positive, but like this. First negative and then positive. At every point sufficient to they are the same thing, maximum. And if it doesn't change its sign, then what's called point of inflection.
Yeah.
Hope you understand. What is this? First derivatives which I already explained, right?
Yes.
Yeah. All points of local maxima and local minima of the function f given by this. This is differentiable. So differentiable means there's no problem in this. Yes, Meryl.
Yeah.
So 3x square minus 3. So if you take 3 common, x equal to minus 1 or plus 1. These are
Yeah.
turning points, right? That means
Yeah.
points of local maximum or local minimum. But how do you check this? By using first principle. Should I check and show or you will check?
So can you show?
Yeah. What happened? Feeling little dull? And
Sorry, sir?
you are feeling little dull today?
No, sir. I'm fine. Yeah.
You are angry with me or what?
No, sir. I'm just I'm just tired, that's all.
Yeah. I should have messaged you 12:45 because 12 o'clock means at definitely it will happen 12:10, 12:15. And then half an hour is lunch. So
Mhm.
I take like
No,
12,
it's
15 like that.
okay. Yeah, it's fine, sir.
Okay, so after lunch, then 10, 15 minutes of rest also required, but today's somehow yesterday's class was. Yeah, okay, anyway. So yeah, now you need to apply first principle because first principle of first derivative test we learn. So now you need to apply first derivative test. So we'll apply first derivative test here. Find all the points of local maxima, local minima of the function f given by this. So first we find f dash of x and then 3x squared minus 3 and we equate to 0 because when you equate to 0 you get turning points, that is 3x is
Yeah.
equal to 3 and x equal to x square is 1, x equal to plus minus 1. Okay,
Yeah.
now you see, now what we need to do, we need to find out points of local maximum, local minimum, but we know here 1 and minus 1 are the
Yeah.
turning points. We know either this the f dash of x equal to 0 means what, either they are turning points or
Yeah. Or did not
points of,
different.
yeah, points of inflection also possible. If dash of x equals 0, point of inflection also not is possible, but we need to check now here. So what is that now? If dash of x is what, 3, if I take common x plus 1 into x minus 1. First you need to write this one, f dash of x, you need to write this. This is important to write.
Yeah.
F dash of x. Now you see, what do I do now? Plus 1 I take, x equal to c. C is what here now? Plus 1. C is what? Plus 1. So now for this little left and little right, I have to check, right? Now h equal to x 0.1. Now c minus h. So little less than 1. C minus h. Okay, x equal to c minus x. F
Yeah.
dash of x is what for c minus h? C minus
Mm-hmm.
f dash of x. C minus h, I write 1 minus 0.1 is 0.9. For 0.9, definitely less than 0. Yes or no?
Yeah.
Yeah, good. Now c plus h, it is definitely greater than positive, positive. This positive is positive. So that means what?
Yeah.
Negative to positive. है ना? So negative to positive, that means what it will have? Minimum.
Mm-hmm. Yeah.
If dash of x is negative, means what? The first decrease and then increase. Okay, you understand? So the next what we take minus 1. So f dash of minus 1 we take. F dash of minus 1 minus h. Okay, c minus h. C is minus 1. Okay, then what will happen here? Negative, na? This is negative. Understand? This is also negative. Minus
Yeah.
minus 1
Yeah. Right.
negative. This is
Right.
also negative. Both are negative. Greater than zero. First increase, then f dash of minus 1 plus 0.1.
Yeah.
So plus h. Now what will happen is actually, if you substitute here, this is negative, and if you substitute here, this is positive. Positive,
Yeah.
negative.
Mm-hmm. Yeah.
Simply substitute it here. Substitute 0.1. If you substitute here is 0.1. Okay, here minus 2.1. Yeah. Negative to positive is negative. That means what? Increased. First greater than 0 increase. That means here like this. It's first increase, and then what happens? Then decrease like this. The curve is like this finally. That means what? At minus 1. X equal to minus 1 is the point here, and then this point is what? X equal to 1. Like this. So this is a curve like this. So first increase and then decrease. So therefore, this is got maximum point is. So this is called point of local minimum. This is called point of local maximum. That is how you need.
Okay. Yeah.
So here
Yes.
that is the reason he gives. You have dash of x greater than 0 for all the values close to 1 and left side of 1. And if dash of x less than 0, all the values in right side of 1.
Yeah.
Now what decreased, all are decreased and then increase. So therefore, it is minimum.
Yes.
Can we try this? All the points, same thing.
Mm-hmm. Yeah.
But here, if you observe this, f dash of x is x minus 1 whole square. That means what? Only one critical point you have.
Yeah. Right.
But actually, if you check at x equal to 1, whole square is there. When whole square is always positive. F dash of x is whole square,
Yeah.
always positive,
Yeah.
left side, right side. So it doesn't change
Right.
its sign. When it doesn't change its sign, it means what? It's point of inflection. Okay.
Right.
So
Right.
kind of inflection. Now we'll go to second derivative test, and there's no proof for this. Second derivative is direct. What is that? A function
Mm.
find on interval I, first thing, and C is any point in I such that f is twice differentiable at C. Okay, and
Mm-hmm.
f dash of C is 0 means what it is? F dash of C means what? Possibility that local maximum or local minimum. But how do you check if double dash of C is less than 0? It is maximum. Okay, f of C is local maximum value of f. That means it has maximum at C. Or you can say like this: if x equal to C is a point of local maximum,
Mm-hmm.
then what? F dash of C is 0 and f double dash of C is less than 0.
Yeah.
If it is local minimum, it is greater than 0. I think f
Mm-hmm.
dash of C is greater than 0. In this case, f of C is local minimum. Yeah. The test fails. Yeah, this is very important to remember. The test fails. F dash of C is also 0, f double dash of C is also 0. Okay, f dash
Mm-hmm.
0, f double dash of 0 is greater than 0, less than 0. Less than 0 means what? Maximum. Remember, less
Mm-hmm.
than 0 means maximum, greater than 0 means minimum. And if
Yeah.
C is 0 means what? Test fails.
Yeah.
In this case, we go back to first derivative test. In which case, f dash of C equal to 0. That means what? Actually, local maximum, local minimum, we are not able to understand. Then we go to first derivative.
Okay.
Now, question example 31.
Hmm.
Not differentiable at 0. Sir, no, obviously, no, mod x not differentiable at 0.
Right.
That means what? At 0 only it can have local maximum or local minimum.
Yeah.
If dash of c equal to 0, also okay, or not differentiable, also okay. Here, not differentiable,
Yeah.
x equal to 0. So, at 0 only it can have maximum or minimum. You need to check that. How do you check?
Okay.
Of course, this one. This what is that? Mod x is greater than or equal to 0. Mod x plus 3. Mod x plus 3 is greater than or equal to 3 because you are adding 3 on both sides. Therefore, is f of x always greater than or equal to 3 to
Yeah.
3. So, what is 3? 3 is what is minimum point of local minimum.
Mm-hmm.
Like this, modulus all you can do directly.
Okay.
Yeah, you do this. Find local maximum, local minimum values of function f given by this. Quickly you do. Once you do, just I'm Did you finish?
Yeah. Yeah, I got it.
Okay. First, you have to make f dash of x 0. If you make f dash of x 0, then you get the turning points 0, 1, minus 2.
Yeah.
These critical points, it is critical points. You may have maximum, local maximum, or local minimum, or whatever point of infection also possible.
Yeah.
Hmm. But f double dash of x, if you find this is f double dash of x, and here, if you substitute 0, 1, minus 2, 0, if you substitute less than 0, that means maximum.
Hmm.
F double dash of 1 is what? Greater than 0, that means what is minimum? Greater than 0 means
Hmm. Yeah.
that means what? What did you understand from this? What is the conclusion?
0 is the point of maximum, and 1 and 2 are minus 2 are points of minimum.
Okay. How can there be two minimum?
Local.
Good. Good. Now, what we need to discuss is this is fourth degree polynomial.
Yeah.
A fourth degree polynomial definitely will have three turning points. Second degree, one turning point. Second degree means what? Parabola, one turning point.
Mm-hmm.
You
Okay.
have graph like this, the two turning points. Yes or no? Third degree means what? Second degree differentiation is
Yeah.
two turning points. Fourth degree,
Yeah.
three turning points,
Yeah. Right.
Graph approximately I am drawing this graph.
Yeah.
Okay. This graph I am drawing approximately. First of all, at 0 you have maximum.
Mm-hmm.
Yes or no? At 0
Yeah.
you have maximum.
Yeah. Right.
Minus 2 you have minimum.
Yeah.
So I'll write minus 2. And
Yeah.
I write then minus 1 is, let's say here 0. And I write 1.
Yeah.
Minus 2 it has minimum. Like this graph is like this.
Yeah. Yeah.
Minus 2 it has minimum.
Okay.
And then what? At 0 it has maximum. Like this.
Yeah.
Like this. Maximum.
Yes.
Hmm. Again at 1 we have minimum. Local
Right.
maybe like this.
Yeah. Yeah.
Minimum, this is maximum, this is local minimum. Yeah, may not be like this, but it can be approximately I'm saying it can be like this.
Yeah. Right.
Graph. You can graph a car, graph you can draw. How? You substitute f of 0. F of 0 is what? 12.
Mm-hmm. Yeah.
F of 0, this is 12.
Yes.
Y
Okay.
axis and this is 12.
Right.
And minus 2 is substitute in this, minus 2 is substitute. Minus 2 if you substitute, you get this value. This length you get.
Right.
And 1 you substitute. If you substitute 1, f of 1 I know. See? F of 1,
Yeah.
3 plus 4, 7. Minus 12 plus 12 cancel. 7, 7, this is like this is positive. This is 12 and this is 7.
Yeah.
Huh?
Yeah. 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 Right.
Like this you can draw exact graph. Like this it is.
Yeah. Yeah.
Find all the points of local maxima and local minima of the function f is given by m. Already we saw that is point of inflection because just by seeing x minus 1 whole square, you can say f dash of x is not changing its sign from left to right or right to left. Yes or no?
Yeah. Right.
Point
Right.
of inflection.
Yes.
Remember this.
Yeah.
But anyway, f dash of x is equal to 0, f dash of x is equal to 0, then x equal to 1. Yes or no?
Yes, sir.
We'll do second derivative test. If you do second derivative test, what will happen? F double dash of x. F double dash of x is at x equal to 1, what? X equal to 1 is a turning point. F double dash of 1 is what? 0.
Yeah.
If it is less than 0, max. Greater than 0, minimum. Equal to 0, then what? Test fails.
Yeah.
If test fails,
Right.
go first derivative test.
Right.
First derivative test, what will happen? If you substitute in first derivative test, left side or right side only whole square positive, it's not changing its sign. Therefore, that's called point of inflection.
Okay. Right.
So here what is given? F dash of x equals 0, x equal to 1. Also f double dash of 1 also 0. F dash of 1 0, f double dash
Ah,
0.
yeah.
Second
Yeah.
test
Yeah.
fails in this case. So
Right.
back to first derivative test. And we have already seen in the example that x equal to 1 is neither point of local maximum or minimum. So it's called point of inflection.
Right. Right. Yes.
Okay, then we'll go to next. Yeah. Example 35, once you can try. Example 36, I'll tell you example 36, 37, like that we'll discuss. 38. These are word problems, very, very important. These problems only come.
Yeah.
The next, maximum minimum values of function in a closed interval. In the closed interval, already we discussed, in the closed interval,
Yeah.
only increasing function.
And increase, it'll be the
It is-
endpoints.
Yeah, good endpoint. So f dash of x is just increasing, only increasing, greater than 0, not equal to 0, greater than 0. Or if dash of x is less than, it means what? Increasing also no problem, completely increasing or completely decreasing no problem. But f dash of x equal to 0. That means what? Turning points. It's not increasing or decreasing. It has turning points also. Yes, sir?
Yeah.
So
Yeah.
if it has turning point, then you need to find out. So in the closed interval, he's saying in the closed interval, let's say in the closed interval is like this.
Right.
Although when you have closed interval, then only problem comes because no, here this is maximum, this is also maximum. So therefore, this is called local,
Yeah.
this is called absolute maximum. This is what is minimum. This is also minimum. But this is
Yeah.
local minimum. But this is possible only when you have this is closed interval only. You can
Right.
maximum absolute minimum you can talk only in the closed interval. If it is open interval, so like this it will go and it will go like this. You cannot
Yeah. Local.
absolute maximum, you cannot speak about absolute minimum. You can only speak about local maximum, local.
Local. Yeah. Yeah. Right.
That's what you mean to say closed interval.
Okay.
Then we'll go for exercise only. We'll go. Yeah, this is what he gave. Whatever I told you. Working rule for that is given. This is example. Here, third degree means how many turning points you get?
Oh. 2.
2 turning points plus 2 end points. Total 4 points you need to check.
Okay. Right. Right.
So here what we got is 1, 5 and 3, 2. Okay, then f of 1, f of 2, f of 3, f of 5. You checked all these things. Right?
Yeah.